In the annals of celestial events, the year 2025 is poised to witness a spectacle of cosmic proportions. This extraordinary occurrence, christened the Seven Comet Swarm, is a rare and captivating convergence of 7 comets, each with its unique history, characteristics, and orbital path, racing towards our Sun. This convergence is not only unprecedented, but is accompanied by the close approach of an interstellar object, 3 Atlas, adding an extra layer of mystery to this celestial spectacle. The 7 comet swarm consists of Pan-stars, Swan, Stereo, Atlas K1, Atlas G3, Lemon, and Neat. Each comet follows an independent orbital path, shaped by gravitational forces that have been shaping their trajectories for millions of years. Their arrival within months of each other, however, is unusual and demands explanation. The peculiarity of the 7 comet swarm is further accentuated by the presence of 3 Atlas, an interstellar visitor. The odds of such a coincidence are astronomically small. Could there be a connection between these arrivals, or is it merely a coincidence of cosmic proportions? To investigate this possibility, we will delve into the history, characteristics, and orbital dynamics of each object. Let us begin with the 7 comet swarm. Each comet carries its story of formation in the outer solar system, gravitational perturbations that initiated its current orbit, and response to increasing solar radiation as it approaches the Sun. Their arrival in 2025 represents a rare opportunity for comparative comet studies and deeper understanding of outer solar system dynamics. Pan-stars, the brightest and most accessible of the comets, is expected to reach naked-eye visibility for Northern Hemisphere observers. Discovered by the Panoramic Survey Telescope and Rapid Response System, it promises to be a spectacle worth witnessing. Its brightness and accessibility make it an ideal starting point for our investigation. Swan, discovered by the Solar Wind and Isotropies spacecraft, is unique due to its ongoing outgassing, indicating that it was active for months, possibly years before its discovery. This hydrogen signature tells us something important about Swan's activity level. Its ongoing activity suggests that Swan may be a more active comet than others in the swarm, potentially offering insights into the factors that determine a comet's activity level. Stereo offers perhaps the most dramatic discovery narrative. Solar observation spacecraft positioned to monitor our star's activity accidentally became comet hunters when their hydrogen detection instruments began spotting the characteristic glow of comet atmospheres. Stereo comets often become suicidal solar grazers, racing so close to our star that they either disintegrate in spectacular fashion or emerge fundamentally altered by the experience. The study of these comets could provide valuable insights into the behavior of comets under extreme solar conditions. The timing of Atlas K1's arrival within the swarm window is intriguing. Its discovery date places it squarely within the swarm timeline. However, its orbit refines through thousands of observations, suggesting it's been following this path for thousands of years. Why are we finding it now? Why this year when 6 other comets crowd the same observation window? The study of Atlas K1 could potentially offer insights into the long-term predictability of comet orbits and the factors that affect their visibility. Atlas G3 shares the same survey heritage as its K1 sibling, discovered by the same Hawaiian telescope system that's become remarkably efficient at finding potentially hazardous objects. The visual expectations for Lemon remain modest, likely a binocular object at best, but its position in the swarm sequence is precisely what makes it interesting. Lemon arrives in the middle of the pack, neither leading nor trailing the group. It's positioned like a placeholder, maintaining formation with mathematical precision that seems unlikely to emerge from purely random orbital mechanics. The study of Lemon could potentially offer insights into the stability of comet swarms and the factors that maintain their cohesion. NE8 rounds out our septet with a touch of historical irony. The Near-Earth Asteroid Tracking Program ended operations in 2007, but comets discovered during its active years continue arriving on schedule, following orbits calculated decades ago. NEAT represents the legacy of systematic sky surveys, proof that patient observation eventually pays dividends. The study of NE8 could potentially offer insights into the longevity of comet orbits and the factors that affect their stability over long periods. The timing of these comets' arrivals raises questions that keep astronomers awake at night. Is it pure coincidence that our solar system's most unusual comet year in recent memory coincides with a visit from an interstellar stranger? Or could there be something more deliberate at work? The answer to this question could potentially reshape our understanding of the universe and the forces that govern its behavior. 3 Atlas, the interstellar visitor, adds another layer of mystery. Unlike our 7 Comet Welcoming Committee, this visitor wasn't born here. It formed around another star in another planetary system, and it's passing through our neighborhood on a one-time hyperbolic trajectory. Its chemical composition holds clues about planetary formation in other solar systems. Its behavior as it approaches our sun reveals how materials from elsewhere respond to stellar heat. But what if its arrival isn't as random as we assumed? What if the same force that potentially herded 7 Earth-born comets also guided an interstellar visitor toward our solar system at precisely the right moment? The questions multiply like fractals, each answer spawning new puzzles. How would we even detect such influence? What kind of mechanism could operate across the vast distances of space to coordinate objects with such precision? And if such coordination is possible, what does that tell us about the true nature of our cosmic neighborhood? Our test is simple but rigorous. If 3 Atlas is somehow connected to this 7 comet swarm, that connection should leave observable signatures, timing correlations that exceed statistical probability, orbital relationships that suggest more than coincidence, physical interactions that can be measured and verified. We're not looking for subtle hints or vague fintes, patterns that require creative interpretation. We're hunting for concrete, quantifiable evidence that would convince the most skeptical astronomer, the kind of data that transforms speculation into scientific fact. The stakes of this investigation extend far beyond academic curiosity. If these 7 comets arrived independently, following nothing but the cold mathematics of orbital mechanics and the random discoveries of survey telescopes, then we're witnessing a remarkable but perfectly natural celestial coincidence. The universe is vast enough to occasionally surprise us with clustering that feels meaningful but isn't. However, if some external influence, whether gravitational, electromagnetic, or something we haven't considered has nudged these objects toward synchronized arrivals, then we're looking at evidence of forces operating on scales we barely comprehend. Forces that could reshape our understanding of how objects move through space. As we prepare to examine each member of this unusual 7 comet cast, remember that the universe rarely reveals its secrets easily. Every discovery begins with an observation that doesn't quite fit the expected pattern. Every breakthrough starts with someone asking why things aren't quite as simple as they appear. The swarm has arrived, and with it questions that may challenge everything we think we know about how our solar system works. But first, we need to understand why this level of clustering strikes experienced astronomers as genuinely unusual. And that requires examining what normal comet years actually look like. To fully appreciate the significance of the seven comet swarm, we must first understand the typical behavior of comets in our solar system. A normal comet year is characterized by the arrival of a handful of comets, each following its unique orbital path, shaped by gravitational forces and the occasional close encounter with other celestial bodies. These comets may display a variety of behaviors, from distant, dim objects that require powerful telescopes to observe, to bright, easily visible objects that can be seen with the naked eye. However, the arrival of 7 comets within a relatively short period is unusual, especially when they maintain a relatively close proximity to each other as they approach the Sun. In a typical year, comets may arrive at the Sun from various directions and at different times, allowing for a greater degree of dispersion. The close proximity of the 7 comet swarm suggests that they may have been influenced by some external force, potentially coordinating their arrival, in a manner that would be difficult to explain through natural orbital mechanics alone. Another factor that sets the 7 comet swarm apart is the diversity of their origins and characteristics. Comets can be divided into 2 broad categories: short-period comets and long-period comets. Short-period comets have orbital periods of less than 200 years and are thought to originate from the Kuiper Belt, a region beyond the orbit of Neptune that is home to a large population of icy bodies. Long-period comets, on the other hand, have orbital periods of more than 200 years and are thought to originate from the Oort cloud, a hypothetical sphere of icy bodies located at the outermost edge of the solar system. The 7 comet swarm consists of both short-period and long-period comets, suggesting that they may have originated from different regions of the solar system. This diversity adds complexity to the investigation, as each comet may have been influenced by different gravitational forces and experiences during its journey through the solar system. In addition to their diverse origins, the 7 comet swarm also displays a wide range of behaviors and characteristics. Some comets, like Pan-STARRS and Swan, are expected to reach naked eye visibility, making them easy targets for observation by amateur astronomers. Others, like Lehman and NE8, are expected to be more difficult to observe, requiring powerful telescopes and careful observation techniques. The diversity of the 7 comet swarm also extends to their physical characteristics. Some comets, like Stereo, are expected to be active, releasing large amounts of gas and dust as they approach the Sun. Others, like Atlas K1 and Atlas G3, are expected to be more inactive, releasing relatively small amounts of gas and dust. This diversity raises questions about the factors that determine a comet's behavior and characteristics. Is it simply a matter of chance, with each comet following its own unique path through the solar system? Or are there underlying patterns and connections that have yet to be discovered? To answer these questions, we must first gather data on each member of the 7 comet swarm. This data will allow us to compare and contrast the behaviors and characteristics of the comets, potentially revealing patterns and connections that would be difficult to discern through individual observations. One of the key pieces of data that we will collect is each comet's orbital path. By understanding the path each comet follows, we can gain insights into the gravitational forces that have shaped its trajectory and the factors that have influenced its behavior. Another key piece of data that we will collect is each comet's activity level. This data will allow us to compare the behavior of the 7 comet swarm as a whole, potentially revealing patterns and connections that would be difficult to discern through individual observations. In addition to gathering data on the 7 comet swarm, we will also examine the behavior of 3 Atlas, the interstellar visitor. By understanding the characteristics and behavior of this object, we can gain insights into the forces that govern the movement of objects through space and the factors that affect their behavior. The study of the 7 comet swarm and 3 atlas will require a multidisciplinary approach, combining the expertise of astronomers, astrophysicists, and other scientists. This collaboration will allow us to approach the problem from multiple angles, potentially revealing new insights and connections that would be difficult to discern through individual efforts. The investigation of the 7 comet swarm and 3 atlas is expected to take several years, as we gather data, analyze the results, and refine our understanding of these celestial bodies. However, the potential rewards are immense. If we can determine the cause of the 7 comet swarm and the connection, if any, between the swarm and 3 atlas, we could potentially reshape our understanding of the universe and the forces that govern its behavior. In conclusion, the 7 comet swarm and 3 atlas represent a rare and captivating convergence of celestial bodies, offering a unique opportunity for scientific discovery. By studying these objects, we can gain insights into the forces that govern the movement of objects through space, the behavior of comets, and the characteristics of interstellar visitors. The results of this investigation could potentially reshape our understanding of the universe and the forces that govern its behavior. As we embark on this journey of discovery, we invite you to join us. Whether you are an amateur astronomer, a professional scientist, or simply a curious observer, the 7 comet swarm and 3 atlas offer a rare opportunity to witness the awe-inspiring majesty of the cosmos and to contribute to the advancement of human knowledge. So grab your telescopes, log into your favorite astronomy app, and join us as we delve into the mysteries of the cosmos. Who knows what we might discover?